Okay, there was some interruption. Now we are moving to 3 volt. This is 3 volt and then another 3 volt. Okay, here you can see the reading is 2.763 milliampere and here it is 4.120 milliampere at 3 volt. Okay, let's see up to up to 7 volt we will go. Okay. Then make it to 4. And again here also we will make it to 4. Remember, both the V1 and V2 should be in tracking mode, means both the voltage should be same. Now here it is 4.202 milliampere and it is 5.624 milliampere. This is your LED current. You can see the photodiode current is a little bit higher as compared to the input current, that is LED current. And now 5 volt, again 5 volt. Here it is 5.546 milliampere and here it is 7.040 milliampere. We will go to the 6 volt. Here also we will make it 6 volt. Yeah, it is 7.00 and then 8.568 milliampere. Okay, then go to the 7 volt. So gradually you can see as we will increase the input voltage, okay, more LED will glow. The intensity of the LED is actually providing more light and therefore the internal resistance will be less. And when the internal resistance will be less because we are increasing the current, okay, then what is happening? Your resistance will decrease and your output current will increase. Okay, so this is what happening. So if you see the LED current is 8.400, the output is 10.080 milliampere. Likewise it is happening. Now one last reading we will take for 8. Then another 8. Yes. So you can see it is 9.859 milliampere and it is 11.423 milliamperes. So that's it for this experiment. We will be having this much reading. Let me plot the graph. I will show you how the graph response will be. Just have a look. Okay. So here we will be plotting the graph. In this case, if you see, yeah, here only we are plotting. This is your input current, that is in milliampere, that we are talking about LED. Okay, and this is your photodiode, and this is also in milliampere output. If you are going to plot, and this voltage we are not mentioning, at 0 is equal to 0, let it be 1, 2, 3, 4, 5, 6, 7, 8, 9. Similarly here you can write you can write 2, 4, 6, 8, 10, 12. Okay, if you plot this is gradually will be coming like this. Okay, likewise it will come. It will be gradually increasing. As you increase the LED current, your photodiode current will increase. So this is it for the experiment. Okay, chal raha hai na? This is for the experiment where we have seen how the increase in LED current will result in increase in photodiode current. Now we will do the another experiment, or we will measure the internal resistance of this IC. Okay, it is in mega amp. When there is no current coming or no LED current is current, means LED is not glowing, at that time the resistance will be almost infinite, or it is very very high in mega amp, and gradually will keep on increasing the current, then the intensity of LED will more, means LED will glow more brighter and brighter, then it will decrease the resistance, and you will see the response how the resistance decreases. So we will do the second part where we are having this V2, we'll keep it as 0.1 volt or 0.2 volt. This is for photodiode, okay, it should be constant. And then we are having V1, that is for LED, it is in volt, that is LED side. You will see the output here. You will see the resistance in kilo ohm, and let's say LED current also we will take into picture, LED current in milliampere. So these are the reading we are going to see. Let's see. So what is happening for V2, we will keep it as 0.2, make it as okay. I want to make a slight correction. This portion is for photodiode and this is for LED, okay, and this is giving the current of LED and photodiode, okay. So this is photodiode voltage which we are going to make it 0.1, 0.2 volt, make it 0.1 volt. Just for biasing we are making it 0.1 volt, okay, we make it 0.1 volt, okay. Now make it to 0. Initially this is your V1, this is your V2, okay. Previously it was in tracking mode, so no issue which one is V1, which one is V2, but for this case you should be very clear, this is V2 for photodiode and this is for LED. Make it 0. In connection we have to make change because we have to measure the resistance at the output. So we will change the terminal from this current to this volt and resistance, you can see, and take the knob to the resistance part, okay. So if you see, initially at 0 volt the resistance is almost very high, not coming in picture, okay. Let me give some voltage, let it be some voltage 1. Still it's a very high current, I think. Is it fine? I think it is fine, okay. So initially let's see, let it be 0 only. At 0 current is 0 and resistance we cannot define, it is not there, okay. Here V2 is 0.1 volt. Now we gradually increase this to 1 volt. See what is the response. Yeah, still let me verify, then I will go further. Okay, so actually because of the scale it was not coming, we have to keep in mega ohm only. So when it is 0, when it is 0, if you see, it is almost let me come, it is out of the scale, okay. Let it be 0.1 volt, then we will see, still it is not coming, we will make it to 1 volt. Yeah, now it comes. So we will write the reading 1 volt, the current is 0.118 milliampere and the output resistance is 10.89, you can say, or almost 11.09. This is in mega ohm, okay. Now we will make it to 2 volt. What is actually happening in this thing, when you are increasing the voltage, the LED current is increasing. See, it is increasing. At 2 volt it is 1.363 milliampere. The resistance will decrease. Now it is coming make it mega ohm only. Now it is coming 0.437 mega ohm. Okay, now make it 3 volt. At 3 volt the resistance is the LED current is 2.816. As the LED current will increase, the more intensity of LED light is there and the output resistance will decrease. You can see not a much decrease, but it is 4.31 mega ohm. I think for 4, let's see. Okay, we have to increase the current further, make it 5 volt. Okay, let me see some reading, then we will see what is actually happening. It has to decrease. Okay, we have to increase some interval. Let it be 5 volt. At 5 volt the current is 5.441 milliampere, but the output is 4.28 milliohm only. It is not increasing much, so we will go to 7 volt. We will go to 7 volt. We will give some higher voltage. Okay, at 7 volt, yeah, at 7 volt the current is 8.471 milliampere and it is in 427 mega ohm. Still it is not responding good. Let's move to 9. I think we have to change the scale to have a good reading. Yeah, I think we have to change the scale. Now we are getting good reading. So at 9 volt, it is coming 10.600 and the current is 5.30 kilo ohm. For rest also we will check. Okay, because of the scale we are not getting the reading. We have now changed the scale. I hope we will get the reading. Make it go to the 7. Check 1 again. Yes, so we are getting 5.46 kilo ohm. Okay, yes, it is little bit correct. Here we will make another reading. Here only 5.46 kilo ohm. Then for 5 volt, it is 5.8 kilo ohm, 5.81 kilo ohm. Okay, for 3 volt, no, not go for the lower value. We will move to the higher value only, or let it be 3 volt. Just for one reading we will see, and then we will move to the higher voltage. 3 volt, it is 27.72 kilo ohm, 27 point, or you can say 28.15 kilo ohm. So because of the scale, it is having a drastic change which can be more visible. Okay, yes, at 2 volt it was 172.79 kilo ohm. Okay, at 1 volt, let's see whether it is coming in the range or not. It is out of the range. Okay, anyway, so this is fine. Now we will move to 11 volt. Let's see what is happening. At 11 volt, the current is 14.058 milliampere and the resistance is 5.22 kilo ohm. It is decreasing. Then we are going to 13. it is 17.021 and the resistance is 5.19 kilo ohm. This, I think this is the last reading we will go. Now the resistance is not decreasing that much. It means this is the best which can be done by the LED. Let it be 15. Again it is 5.17 milliohm kilo ohm. 5.17 kilo ohm and the resistance current is 19.897 milliampere. So if you are going to plot the graph in this case, okay, I think this is the output, which is resistance, and that should be in kilo ohm, and this is your LED current, that should be in milliampere. Okay, this voltage is for our reference, so we will not go in that detail. Okay, no, it should be in voltage only. Okay, for any case you will get the results, not an issue. So it's better we should take V1 or LED voltage. Okay, if you see at 0 volt it is almost, somewhere we can't predict. At 0, 1, okay, then you can see it is 1, it is 2, 3, 5, 7, 9, 11, 13 and 15, and similarly here we are having the values. Okay, it's a very high scale, we have to keep in mind. It gradually at 0 it is in infinite, we can't track it down. At 1 it is 11.9 mega ohm. So let it be very high value once again. Suppose it will be 200 kilo ohm, then 150 kilo ohm, 100, 50, 200, 150, 150 and 25. Okay, likewise if you plot, then you can understand. So some values will come like 172 at 1 volt, at 2 volt, 2 volt it is here, then at 3 volt it is 28, let it be here, then at 5 volt it is 5 point, let it be here, and gradually it will constant, means it will comes like this. I'm not getting the exact graph, but gradually it will be becoming constant. Okay, that this range is coming in the range of 5 kilo ohm. Okay, this is what happening. So after some voltage like 5 to 7 volt, the resistance is going to be constant, it is not changing much, but initially it is in mega ohm, let's say 11 mega ohm, very high. So I didn't able to plot the graph very well. The graph slope will be something like this. It will like this, and again it will after some time it will be constant. So likewise you are going the output or input response. So this is what we are getting the response. So this is all for this experiment, where we are going to measure the output resistance with the respect of input voltage. Okay, thank you very much.